All right,
Okay.
sweet.
Bill, you want to do introductions?
Sure, I'll do intros. So welcome back everyone to second session of coding interview crash course. We're going to be going over arrays and strings and common problems as well. Yeah, I guess to reintroduce us, if you guys don't remember, or if this is your first time here, I'm Bill. I'm a third year CS major and one of your co-leads for coding interview crash course.
I'm Alvin. I'm your other lead. I'm also a third year.
I'm Arjun. I'm a fourth year, and yeah.
All right, let's begin. First off, it's 6:05. The attendance code should be up. Here is your attendance code. It's #_Brown. So that's going to give you a clue to a type of problem we're going to be covering today.
Oh yeah, also an announcement before we get any further. If you have any questions that you want to see us address specifically, please put @question in front of the question. That way we know what questions you want us to answer, and we'll go to those first. Generally, we want to interact with the chat as much as we can, but that way it gives us an easy way to prioritize questions. Yeah, exactly like that. Great stuff. All right, you can continue, Alvin.
Okay, and here are the links to the slides. We got coding interview crash course right, but apparently not lesson. I just figured this out now, but that's all right. Nikhil, what are you thinking? Nikhil likes it, so that's all
now it's tradition. We have to get something wrong about the link every time.
All right. Is everyone who has the slides, who wants the slide, has it yet? I'll give you a few more seconds.
I typed it in chat for everyone.
Oh, thanks, yes. Daniel.
Lesson 2. Let's go. All right, so let's do a little bit of a review about arrays. I'm sure everyone here has a lot of experience with using arrays, but here we go. Arrays are a collection of items stored at a contiguous memory locations. Notice how contiguous is bolded. This is the defining feature of arrays. Arrays are all stored together in memory, which makes it easy to get any particular index. All you have to do is do a little bit of calculations. Under the hood, the computer does a few calculations to grab any index that you want, which is what leads to an access of O of 1 runtime. And items are not stored in any particular order. You can store in any order that you want. And typically the same type of items can be stored together. And here is there's a little mini big O table that talks about the common operations you'd want to do with your basic data structures. You're going to be seeing this a lot in our slides. This will show you the runtimes for common operations for different data structures. For arrays, an access is O of 1, but if you want to search, insert or delete, they're going to be O of n. Does anyone here want to explain why search, insert, and delete are O of n? Or you can just do one of the three.
At its worst case, you'd have to search every element if it's unsorted, that is.
Yep, because items aren't stored in any particular order, right? How about insert and delete?
Well, since it's contiguous memory, you have to shift all the other elements in the array to put a new one in or to take one out.
Yep, good job. Okay, so I'll take if anyone wants to like, I think you guys may all like sort of just memorize this or know this from experience, but if you don't, I'll give you a few seconds to look at it. Okay, so now we're going to talk a little bit about vectors. Arrays in C++, this is more of a C++ lesson. Arrays in C++ are a bit hard to work with. They're not like dynamically sized, and that's a big deal when you want to increase or decrease the size of your array. You'd have to use like a bunch of dynamic arrays and like a lot of pointers and like reshifting. It's a hassle. So you're more likely going to be dealing with vectors than arrays. But vectors, they're a template class that act as an array of dynamic size. So they have like extra operations like changing the size of the array. And they can use like STL, so standard library functions. They can be deep copied, which means when you make a copy of them, it's not going to be a pointer to like the same reference. And they can be returned from a function. These are all things that arrays generally can't do on their own. So first, if you want to use them in like your C++ program, don't forget to do your like hash include vector. And then here are your basic vector functions. You can use you can use the brackets operators similar to arrays. So that would be like, I'm gonna type it in the chat, vect0 like that if you want to access this, if you want to access the first element. You can also do pushback. Pushing back is increasing the size of the array by 1 and adding a value. Pop back decreases the size by 1. Insert, you can insert a value at any position. It doesn't just have to be the back. You can also erase a certain position. You can get the front value, the back value, and then you can also get the size of the vector in general. The operations that are highlighted in red have to do with return iterators, and that can be a bit of an advanced concept because iterators they act as pointers, so it may be a bit confusing. So I have them colored red just for reference. Be careful when you use these. Oh yeah, so we have a meme here. Arrays in most programming languages start at 0. However, there is one imposter among us. So one of these, this is a bit of a trivia question, but one of these programming languages has arrays that are indexed starting at 1 instead of 0. Can anyone guess which one it is? Yeah, okay, it's not C++ or JS. What about Python? Python indexed at 0? Yeah, not Python. Okay, a lot of people know it's not Python. Anyone use Go here? Daniel thinks it's Go. It actually is not Go. Go is indexed at 0. So we have 2 choices left, Lua or R. A lot of people are saying it's Lua. Is it Lua? Because when I didn't know this, I didn't know the answer to this, but when I looked it up, it said that R was the programming languages where arrays started at 1. You can usually tell with these languages like R and like MATLAB, they're more of like mathematics statistics type languages. They usually have arrays that start at 1 instead of 0. It's a little fun fact for you guys. Yes, Lua was not the imposter. It was actually R. Okay, so let's move on to a very similar topic. So strings. Strings are can basically be thought of as an array of characters. So you can take any array question and like interchange it with a string question. So like you could, for example, maybe you want to sort an array. You could also just sort like the array of characters. And there's probably a bunch of other examples I'm missing, but you could probably think of one. In C++, this is again another like thing for just C++. Strings are mutable, meaning you can directly modify them. So here, the example is right here. Let's see, we declare a string that's called LeetCode. It will generally look like this, like in memory. It'll be like characters that are stored together. But then you can, modify the first, like index in this array, but it's actually a string. So you can do str bracket 0 equals y. And so you've changed your string from LeetCode to YeetCode. And if you print this out, you're going to get your YeetCode. Notice this may not be the case for other programming languages. This is what makes C++ like really unique, and one reason why I really like it, that strings are immutable, but it's not the case for other languages. For example, you can't do this with Java. For Java, you can declare a string, you can access a certain character, but you can't modify it. So in Java, you wouldn't be able to do str like bracket 0 equals to y. This is something you won't be able to do in Java. I don't think you'd be able to do in Python, but don't quote me on that, but you can definitely do it in C++. And here's some common standard library functions for strings. If you want to use them, don't forget to include, like do your include statements. Oh, whoops. And check the C++ reference for more information on these functions. So you can use like your array operators as usual. You can also concatenating the strings. That's a special function for strings. You can check their size, and then you can also get a substring. Substring here is colored red because this is also different in C++ than in most other languages. In most other languages like Java, if you want to use substring, your first parameter is the starting index, and the second parameter is like the ending index. But for C++, it's a little different. Your first is the same, you have the starting index, but then your second argument is the size of the substring. So this is different from Java, which would have like the ending index. So if you plan on using C++ and you're used to like other programming languages, using like substrings for other programming languages, keep this in mind. This will be really important. Oh man, a lot of, if you use C or C++, you're gonna have to deal with a lot of pointers. So this is something that Bill found. I thought it was pretty funny. Meme game on point tonight. Yes, thank you, Daniel. Thank you, Daniel. Okay, so let's start going into some problems. So it's almost guaranteed that in any like recruiting season, you're definitely going to be asked a problem about arrays or strings. Like pretty much guarantee you'll see that like every season. And unfortunately, there's a lot of arrays and string problems, like a whole bunch. So we won't be able to get through all types of problems in 2 hours. So we're going to be focusing on 2 very common types of problems. We have 2 pictures to represent the type of problems. I don't know if you can make of it whatever you want, but we will start off with this problem, which, can anyone guess what it is? Hopefully you're not going ahead in the slides. Tomato problems. Very, very, I don't know, you're very close. You might want to look a little to the left. Yes, Yes, okay. Breadboard problems, potato problems, hash. Well, that looks like the closest we're getting. Yes, we are going to be talking about hash tables and the problems that like come with them. So hash tables are data structures that map values to indexes for highly efficient lookup. So for example, we have this is a hash table of strings. You take a string and then you're going to pass it through a hash function, which is a very complex but very fast function that gives you an index that you're going to be put into this is in simple terms, is going to be put into an array. You're going to hash a string and you're going to put it into an array. And because arrays are like contiguous memory, you can do access in O of 1 time. So let's say for a hash table, you want to search, is AA inside our hash table? Well, if you want to check if AA is in the hash table, you would compute the hash function, which is very fast. You'd get an index, and then you use that index into the array, which is also O of 1. So that's why insert is O of 1 time. Search is like the same thing as O of 1 time. Delete, if it also very similar, is also O of 1. So it's a very, very fast data structure. Anyone have any? I've covered a lot of stuff so far. Does anyone have any questions?
Wait, why is access not applicable?
Because you're not really accessing a specific index. Like, it wouldn't make sense to say, give me index 0 of the hash table.
Okay.
Does that make sense? I'm just going to assume that it makes sense. Okay.
How is it possible that search is only O of 1? Because there's multiple, like, I mean, each bucket has could have several things inside of it, right?
On average, it's going to be O of 1. This is talking about like the average case.
Okay.
But in like worst case, it may be a little bit slower than this. But like in your general terms, like when you're solving problems, what did Daniel say? Under the hood, your container is way larger than the data. Yeah, basically what Daniel said. In most cases, it's going to be of O of 1 runtime. It's like it's pretty rare, and it probably won't matter for like solving problems, but it can go a little slower than that.
Question.
Yes, okay. Yeah.
Does this hash, so I'm guessing there's like a memory cost or something when it comes to making these tables?
It just depends on how much you put inside the table. So if you put in n entries into the hash table, it's going to be O of n memory, like similar to an array. Like if you have an array of size n, then that's also going to be O of n memory.
Okay. Okay, I see the trade-offs Daniel just mentioned.
Yes. Dang. Daniel, you're come very prepared. No wonder you did so great on that. No wonder you did so great on the interview. All right, we're gonna keep going. Here we go. We have two things you'd use your hash table for. In C++, we call them an unordered set, but everyone just sort of knows it as like a hash set. So a set is just a data structure that doesn't contain like duplicate elements. So you can insert like 2 1s into like a set of integers and it will just come out as 1. You can do find, you can do erase, and then you can do size. Again, find will return an iterator, so this is colored red. Be a little careful if you use find. And then we have our unordered map, which is more commonly known as a hash map, which is a container that stores elements formed like combination by a key in a map. So if you want to insert a key, like let's say our key is AAA, you basically use like array notation. So you could be like map and then in brackets your string AAA equals whatever value you want to put to it. And then you can erase the key, you can get the size of the data structure. And I've said this is the third time I've said this. Don't forget to include your include statements when you're using them. Oh my goodness. How language creators choose the function to get the size of an array. Wouldn't it be great if everyone just used like the same function or like operation to get the size of an array?
On a side note,
Yes.
does anyone know which languages each one of these are?
Come on, I know you guys use programming languages. I know you guys programming. I don't know why you'd be here if you didn't program. What does C++ use? Dot length is Java. Yes, that's right. It's actually a trick question because you can't actually get the size of an array in Java, can you? You can get the size of a vector, and that would be dot size. Yeah, Daniel, dot size and dot length were for C++ vector. Max, I'm not sure about that for JavaScript. I think you can do dot length for JavaScript. Size of, size of is C.
Oh, I think Edmund has a question. He's wondering if unordered map or the other library is the same as a hash map.
I haven't actually heard of the hash map library. I just use unordered map. Bill, do you have?
Yeah, I think the standard library has like set, unordered set, map, unordered map, and the sets and the map aren't implemented using hash tables, but the unordered ones are implemented using hash tables because like hash tables don't have any order associated with them compared to, I think the other ones are implemented using some sort of binary tree.
Yeah, it's used with it's implemented with like a tree.
Wait, just to clarify, so it's like these libraries are like colloquially referred to as like hash maps, right?
Yeah,
Yes.
that was your question, right? Sorry, I didn't get it.
Okay, yeah, no, I wasn't clear. And then which one is generally referred to as a hash map? Unordered map or unordered set?
Unordered map is hash map.
Okay. And then would unordered set generally be called like hash set or whatever?
Yeah. Like
Gotcha.
That's how you C++ is kind of weird that they call it unordered instead of just hash.
All right. Thank you.
You're welcome.
I do think it kind of makes sense because the other implementation is ordered, but I guess it's just like the non-standardization of things is kind of weird.
All right, I think we're ready to move on. Well, actually, Bill, do you want to take a little 5-minute break?
Yeah, I think we can come back at 6:35 before we move into like practice problems. So yeah, everyone get like a drink of water, stay hydrated, and we'll be back at 6:35.
Well, this is awkward. A few days ago, I forgot to press record again, so now it's just me redoing the second part of this workshop all by my lonely self. Hope you guys don't mind. We still have a few things to cover. Hopefully you guys had the chance to do your practice problems. If you haven't, I'll have them on the screen for a few seconds. Here's the first one. And here's the second one. Okay, I hope you guys have seen it and have attempted it. Let's move on. But first, we have a little meme for you Minecraft players out there. And how many of you have coded in Java before, or Java is your first programming language? Fun fact, it was my first programming language. I don't remember if I ever mentioned that. But that's a little fun fact for you. Okay. All right, now let's move on to our next big topic for arrays, which is 2-pointers. So you've already seen 2-pointers if you've attended our previous workshop. And even if you haven't seen our last workshop, you've probably seen or heard about 2-pointers before. So 2-pointers is a general problem-solving technique that involves the use of 2 different iterators to keep track of different information. Iterators might be a bit confusing here. We're not talking about like actual like C++ iterators, but like just indexes that keep track of just different information. It doesn't have to be like an actual pointer. So for example, in this example, we have a solution to the reverse string problem, and we're going to assume that strings are mutable, like in C++. But if they're not mutable in your favorite programming language, you could just adapt it to be reverse the contents of an array, and it would still work the same. So we have a int left and an int right, and there's a bit of a typo here. Let's pretend this says while left is less than right. We swap the indexes of the string at left and right, and we increment left going up and increment right going down. And we do this until left is equal to or greater than right. And this should reverse the string. What's interesting about this solution is that it uses the 2-pointers that is so tricky to people, but this seems like this is probably something you may have implemented before. Our 2-pointers here are our left and right. So as you can see, there's many flavors of like 2-pointers problems, probably some that you've already touched upon. And today in our workshop, we decided to focus on one type of 2-pointers problem, and you will get the chance to practice them. So I will leave these on the screen for a few seconds for you to like take a look at and attempt on your own. If you want to see us go walk through the solutions, please attend like our workshop like live. We believe that's the best way to learn. That's the best way for you to learn. So hope you've gotten this problem, or at least attempted it. Now let's move on to the next one. Ooh, interesting. Well, that was a bit awkward, but we have this slide not shared like in our workshop because this is a bit of a challenge problem. I definitely recommend that you solve the previous problem before you attempt this one, because this is a little bit more involved. It involves sorting an array in linear time if you have the guarantee that there are only 3 elements. And is it possible? And it's actually possible to do it in constant memory and linear time if you use the 2-pointers approach. So if for anyone that wants to attempt this problem, I wish you guys good luck. I'll leave this on the screen for a few seconds. Okay, hopefully you've gotten that down. That is actually the end of the workshop. Unless you want to do some additional practice, which of course I recommend. These go over your general array hash map problems that we went over, as well as some 2-pointer problems. 904 is pretty interesting because it goes over a sliding windows problem, which is a interesting variation of 2-pointers that if you have time, I think you should look into. And so we've reached the end of our workshop, or at least the one that you're watching here today. Even though you didn't attend our workshop live, we'd really appreciate if you gave us feedback, maybe give us advice on how we could improve the videos, improve the workshop in general. And yeah, thank you for listening to me all the way through here, and I will see you guys next week. Thank you.